Okay, so let's look at section 6.2, where we're going to solve a quadratic equation, and we're going to do it by factoring. Okay, so this is where all the factoring techniques from chapter 5 comes back. So chapter 6, once again, is on quadratic equations. And so in this section, we're actually going to start to solve it. Okay, what's important to understand is what the solutions of a quadratic equation are. Okay, sometimes the solutions are called the zeros. And what the solution or the zeros are the x-intercepts of the parabola. And this is called the roots. So these are all the same thing. Solution, zeros, x-intercept, roots. They're synonyms of each other. They all mean the same thing. They all mean the solution or the answer to a quadratic equation. Now, here's my y-axis. Here's my x-axis. If I were to graph my quadratic and it looked something like this, let's say, this is an x-intercept right here, and this is an x-intercept right here. These are the solutions to my quadratic equation, which means it's the zeros, it's the x-intercepts, it's the roots. Okay? So you can have a situation where your quadratic has two solutions. You can have a situation, let's say like this, where you have one x-intercept. Okay, so that means you have one solution. It doesn't matter if it opens up or down. It could open downward, and same idea. Okay, or you can have a situation, let's say like this, or let's say like this, where there is no x-intercept, so there's no solution. Okay, now a quadratic in standard form looks like this, right? Y equals ax squared plus bx plus c. Now, you'll notice here when we solve a quadratic, it equals 0, which is the y value. Now, let's think, why would we replace the y value with a 0? Let's think about what is it that you're looking for. You're looking for the x-intercepts. If you're looking for the x-intercept, what does y equal at the x-intercept? Y equals 0. So that's why your quadratic equals 0. We replace the y with 0 because we are looking for the x-intercepts. So let's look at a couple of examples. Okay, let's look at this one. This is something we should look already familiar. Do you remember seeing this in chapter 4? And we saw it in chapter 5? Okay, so this looks like this. I'm just going to rewrite this. The a value here is 1. Looks like this. Now we have a 0 here because we're solving it. What are we looking for? We're looking for the x-intercepts. We replace y with 0 and we solve for the x-intercepts. Remember, we know that our value is 4 and the s value is -7. Okay, so this is factored for us. So in this chapter, what we're going to do after it's factored, we're going to let each of these brackets equal 0. We're going to let the first bracket equal 0. We're going to let the second bracket equal 0. And then we're going to solve for x. We move the x over, so our x-intercept is 4. We move this over, our x-intercept equals -7, which is exactly what we did with the r value and the s value in chapter 4 and in chapter 5. So this is as easy as it gets because it's factored for us. Let's look at what's more typical. Okay, here's our quadratic in standard form. It equals 0. Remember, why does it equal 0? We are looking for the x-intercepts. What does y equal at the x-intercept? Y equals 0. That's why it equals 0. Now, in order for me to find the x-intercept, I need it to look like this. I need it in factored form. So your first step is always to factor it. So this is, I always look for a common factor first, and there isn't one. I notice I have three terms. This is a trinomial. I know my a value equals 1. So this is where we have the product equals negative 21. The sum equals positive 4. Looking for two numbers that multiply to negative 21 and add to positive 4. And those numbers are 7 and negative 3. They add to 4, multiply to negative 21. We do our two brackets. Okay, let it equal 0. Now, this is my r value, this is my x value. We're going to start letting the brackets equal 0. Okay, and we're going to solve for x. Okay, so I let x plus 7 equal 0. I let x minus 3 equal 0, and I solve for x. So I move that over, x equals negative 7. Move that over, x equals positive 3. And these are my two x-intercepts. So if I were to graph them, I would have x equaling 3 and x equaling negative 7, my two x-intercepts. If I sub negative 7 here, I get negative 7 plus 7, so I get a 0 here. I would multiply it by this number here, which would be negative 7 minus 3, negative 10, 0 times negative 10, I get 0. And the same idea here, this bracket would become 0. Okay, these are our x-intercepts. Let's look at this one. Here is my quadratic. Remember, every quadratic needs to equal 0 because we're looking for the x-intercepts. What do I notice this equals? This equals 1. What does my quadratic have to equal? It needs to equal 0 because I'm looking for an x-intercept, so I make it equal 0 by moving this to the other side. So I get 6x squared plus x minus 1 equals 0. Your quadratic must equal 0 to solve it because you're looking for an x-intercept, and y equals 0 at the x-intercept. So you have this. Now you need to factor it. Okay? Look for a common factor first. Is there one? No. Now you got a trinomial. Your a value, it does not equal 1, so you must do it by decomposition. So I take 6 times it by negative 1, I get negative 6. That's my product. My sum is positive 1. I look for the numbers that multiply to negative 6 but also add to 1. Those numbers are 3 and negative 2. They multiply to negative 6 and also add to 1. Remember, you need to rewrite the middle term, so all the factoring techniques from chapter 5 come back. Okay, so remember, rewrite the middle term. Now you factor by grouping, looking for the common factor between the first two, which is 3x. Divide each of these by 3x. I get 2x plus 1. Take down this sign, look for the common factor here, which is 1. That's why I have this negative 1 here. Divide each of these terms by negative 1, so I get 2x plus 1. Remember, these brackets must be the same, which they are. And then I have 3x minus 1. Now, a lot of people stop here because this is where we stopped in chapter 5, but now we're actually solving. We're looking for the x-intercept, so let this bracket equal 0, and this one equals 0. And this is a situation where my x-intercepts are going to be fractions. So I'm going to take this one, move it over, because I'm solving for x, so it becomes 2x equals negative 1. Divide both sides by 2, so here I have x equaling negative 1/2, and that is one of my x-intercepts. Do the same thing here, and here I have my other x-intercept being 1/2. Okay, so your steps are to make sure that your equation equals 0, your quadratic. Then you must factor. After you factor, you let each of your brackets equal 0 and solve for x, which is exactly what we did here. It equaled 0. We factored. We let the brackets equal 0. Solve for x. This was factored. Okay, let's look at the last two. Again, our quadratic must equal 0. Because it doesn't, I take this 6x and I move it over. Must equal 0. Now I start factoring. I look for what's common first, and this time there is a common factor. It's 3. It's present, sorry, it's the lowest number that goes into 3 and into 6. The x is present in both, so I take the one with the lowest exponent and divide them each by 3x. Then I take my brackets and let it equal 0. Remember, you could put a bracket around it. We generally don't, but this 3x is like a bracket. So let it equal 0. Let this x minus 2 equal 0. Divide both sides here by 3. So I have one x-intercept at 0. The other x-intercept here at 2. Okay, last one. Again, it needs to equal 0, which this doesn't, so I move the 49 over, change the sign. Once again, I look for a common factor, which I do not have. This is not a trinomial. 2 terms, subtraction, perfect square, perfect square. This is a difference of squares, so this is where you have your 2 brackets. Square root the first number goes into each bracket. Plus sign in one, minus sign in the other, and then square root 49. Okay, you're not done. If you're asked to solve, you need to find the x-intercept. So after I factor, I let my bracket equal 0. Or in this situation, my brackets. Move the 7 over, change the sign, divide by 3. So here my x-intercept is negative 7 over 3. Do the same idea here. And here my x-intercept is positive 7 over 3. And I have 2 of them. And that's it.